In triangle ABC, the foot of the perpendicular from A to BC is D. Given that tan B is 4 by 3 and cos C is 15 by 17 and AB equals to 20 centimeters. Calculate without using tables the length of the sides AC and BC and the value of sin A. In the triangle ABC, the foot of the perpendicular from A to BC is D. So we know this angle is 90 degrees. Given that tan B equals to 4 by 3 and cos C equals to 15 by 17 and we have been given AB equals to 20. Calculate without using the tables the length of the sides AC and BC. Now first let's look at the triangle ABD. We have been given tan B equals to 4 by 3. Let's write down tan B equals to 4 by 3. So I can say this is 4x, this is 3x, then this will be by Pythagoras theorem 5x. So we have now in triangle ABD tan B equals to 4 by 3, that's equals to 4x by 3x. Therefore AB equals to square root of 4x whole square plus 3x whole square, that's equals to 5x. Now 5x equals to 20, that will give us x equals to 4. That means BD equals to 4 into 3, 12 and AD equals to 4 into 4, 16. Now we have got BD and AD values. Now we know cos C is 15 by 17. So let us go to triangle ADC now. So we'll write down in triangle ADC. Now what's our approach to solve this problem? Since we have information here, we'll start with this triangle. We know tan B value 4 by 3. So we took them as 4x comma 3x, AD comma BD respectively. By Pythagoras theorem, AB is 5x and we know 5x is given as 20. That means we can easily find out AD, BD. Once we got AD and BD, we go to triangle ACD now. We apply this cos C equals to 15 by 17 logic. And from there, we'll try to understand what will be the values of AC and DC. After that, once we got DC, BC will be nothing but BD plus DC. Then we'll see how to find out the value of sin A. So we'll write down in triangle ADC, given that cos C equals to 15 by 17. That will give us what will be the value of sin C then. Sin C will be 8 by 17 because we have 15, 8, 17 Pythagorean triplet. We have 8, 15, 17. So sin C is 8 by 17, but that is also equals to AD by AC, which means 8 by 17 equals to AD, which we know equals to 16 divided by AC. Simplify that, we will get AC equals to 34. We got AC equals to 34. We already know that AD equals to 16. Now we need to calculate DC value. Once we got the DC value, BD plus DC will be equals to BC. Now let us use cos C, what they have given us. Cos C is 15 by 17, that is equals to DC divided by 34. Now that will give you DC equals to 30. So DC is 30 centimeters. Therefore, BC will be how much? BC will be BD plus DC equals to BC, and that is equals to 12 plus 30, which is equals to 42 centimeters. Now after that, what we need to find out? We need to find out what is sine of A. How to find out sine of A? Because we don't know these angles, but we have right angle triangles here, and we can find out all the trigonometric ratios from these two, angle A from both the triangles. So let's go ahead and write down those angles as x and y. I don't know this, I'll take it as x. I don't know this, I'll take it as y. Now what is sine A? Let's write down. Sine A equals to sine of x plus y, that is equals to sin x into cos y plus cos x into sin y. Sin x means I am looking from here, so my opposite will be 12, and opposite by hypotenuse, or we have opposite by hypotenuse, that's equals to 12 divided by 20. Multiply that with cos y, looking from here, adjacent is 16 and hypotenuse is 34, plus cos x sin y. Cos x will be, adjacent side will be 16 divided by 20, multiply with sin y, looking from y, opposite will be 30 and hypotenuse will be 34. We need to simplify this now, which is equals to 192 divided by 680 plus 480 divided by 680, which is equals to 672 by 680. I can simplify this by dividing by 8. It will become 84 by 85. So sin A, which is sine of x plus y, equals to 84 by 85. AC equals to 34 and BD equals to 42 centimeters. Let's have a recap of this problem. We have been given triangle ABC, in which we have been given AB equals to 20 centimeters, and AD is the perpendicular drawn from A onto BC, D is the foot of perpendicular. We have been given tan B is 4 by 3 and cos C equals to 15 by 17. We started with the triangle where we have information, that is triangle ABD, and we know tan B is 4 by 3. Tan B is 4 by 3, we can take them as 4x and 3x, then it will be 5x on the hypotenuse, or you can also say tan B equals to 4 by 3, that means sin B equals to 4 by 5. So 5x equals to 20, that means x equals to 4. So the remaining sides are 12 and 16. Now this 16 is common to both the triangles. So we can take that information and go to triangle ADC and apply the logic that we have been given when cos C equals to 15 by 17. But we know sin C, that is 16 by AC. So cos C is 15 by 17, sin C will be 8 by 17. So based on that, we know that AD equals to 16, DC is 30 and AC equals to 34. Then BC equals to BD plus DC, which is equals to 42. And then we have to find out sine of angle A. Now here we have a problem because we don't know these angles, but we know that we can find out the trigonometric ratios from this particular angle A in both the triangles, ADB and ADC. So we have taken those angles are x and y, then sine of A is sine of x plus y. We can use compound angles formula, sin x cos y plus cos x sin y. Sin x is opposite by hypotenuse, so cut over 12 by 20, and cos x is 16. Cos y equals to 16 by 34, then cos x equals to 16 by 20 and sin y equals to 30 by 34. We simplified that, we got it as 84 by 85.